Section 1.5, Part 2, Polynomial Inequalities. I'm going to give you a list of the steps for using test points to solve inequalities. Take a minute and pause and write it down, and then play it again and I'll discuss. Step 1 is to rewrite, if necessary, the inequality so that the right side of the inequality is 0. So basically you want to get all the terms on the left-hand side, and then you just want 0 on the right-hand side of the inequality. Then on the left-hand side, we're going to simplify, and then we're going to factor. Okay, so we're factoring a polynomial. The third step is to draw a number line and find and plot the points where each factor is 0, and those are called zeros, roots, or x-intercepts. And then we're going to select convenient test points at each interval to determine the sign of the inequality. We just want to know if it's positive in that section or negative in that section. And then the last part is from the sign chart, we're going to write our solution set of the inequality. Example 1, solve the inequality x squared minus 2x minus 15 is less than 0. Write the solution in interval notation. Okay, and I have the steps here just to remind us. So step 1 says rewrite the inequality so that the right side is 0. And as you can see, we already have 0 on the right-hand side, and all the other terms are on the left-hand side. Step 2 says to simplify and factor the left-hand side. I would pause the video at this point and factor the left-hand side on your own just for practice. Okay, so now when I factor the left-hand side, that's going to give me x minus 5 and x plus 3 is less than 0. Okay, so I just factored the left-hand side. So I've done step 1, done step 2. Step 3 says draw a number line and find and plot the points where each factor is 0. So what I'm going to do first actually is I'm going to find where these equal 0. Okay, so x minus 5 equals 0. And x plus 3 could equal 0. That's going to give me x equals a positive 5 and x equals a negative 3. Negative 3. Now I'm going to draw my number line. And I'm going to put those values on it. So here's negative 3 and here's 5. Okay, so that's step 3. Step 4 says to select convenient test points in each interval to determine the sign of the inequality. Okay, what I'm going to do is I'm going to go ahead here and I'm going to box my two roots. Okay, my negative 3 and my positive 5, just so that they stand out. Now, I have taken this number line and broken it into 3 sections. So I need to pick a test point in each section. So the first section is all of the numbers less than negative 3. So I'm just going to go ahead and pick negative 4. Then I'm going to pick a test point between negative 3 and 5. I'm going to pick 0 because that's easy. And then I'm going to pick a number greater than 5. So I'm going to pick 6. Okay? So that's select the test points and determine the sign of the inequality. And here's what they mean by determine the sign of the inequality. So I'm going to scroll up a little so I have some more room. When I put negative 4 into this inequality, so into here, into x minus 5 times x plus 3. Let's put negative 4 in. That's negative 4 minus 5 times negative 4 plus 3. I'm not worried about what the answer is. I just need to know if the answer is going to be positive or negative. So negative 4 minus 5 is going to give me a negative 9. Again, I'm only worried about the negative. Negative 4 plus 3 is going to give me another negative. And we know that a negative times a negative is going to leave me with a positive. So up here, I'm going to write that this section is positive. Okay, I'm going to do the same for 0. So 0 minus 5 and 0 plus 3. 0 minus 5 is a negative value. 0 plus 3 is a positive value. A negative times a positive is a negative. So this section in the middle is negative. All right, and the last one, 6. Okay, again, I'm going to plug it in. So 6 minus 5 and 6 plus 3. 6 minus 5 is a positive value. 6 plus 3 is another positive value. A positive times a positive is a positive. Okay? All right, then it says, so that was step 4. Step 5 says from the sign chart, write the solution set of the inequality. Okay, so here's what we have to look at. We have to go back and look at what was originally stated. This here says that we want our polynomial to be less than 0. Less than 0. And what that means is it needs to be either negative. Less than 0 means negative. And what they're talking about is we're talking about where is the graph below the x-axis. That's what they're asking for. Where is this graph below the x-axis? Well, when I look at my sign chart, I want the negative section. So that's this middle section right here. How do I write that middle section in interval notation? Well, that middle section is from -3 to +5. And I only want below the x-axis. I don't want on the x-axis, so both of these are going to get parentheses. Okay, so my solution is -3 to 5. Now I just want to show you exactly what that means, okay, graphically. What that's showing us is that if we have a graph of this polynomial, and the polynomial was y equals x squared minus 2x minus 15, okay, that was what we started with originally. If I were to graph that, it would cross at -3 and 5. All right, I know that this is a parabola that opens up. Okay, I don't know exactly what it looks like, but you can see that everywhere in this section from -3 all the way to +5, that the graph is below the x-axis. So we know how to graph y equals x squared minus 2x minus 15. Now we know how to answer the question x squared minus 2x minus 15 is less than 0. It's simply asking where is the graph below the x-axis. To solve the inequality, 25x squared plus 5x is greater than or equal to 6, and write the solution in interval notation. So look back at your steps. Step 1 says that we need the right-hand side to equal 0. Everything else needs to be on the left-hand side. So to do that, I'm going to subtract 6. So that's going to leave me with 25x squared plus 5x minus 6 is greater than or equal to 0. So now I have 0 on the right-hand side. The next step is to factor the left-hand side. Again, I would take a minute, pause, factor it on your own, and then check with my factors. When you factor 25x squared plus 5x minus 6, that leaves you with 5x plus 3 times 5x minus 2. And again, we want that to be greater than or equal to 0. The next step is to find where these equal 0. So I'm going to find the roots. So 5x plus 3 could equal 0, and 5x minus 2 equals 0. Solve both of these. That gives me 5x equals -3. So x is equal to -3/5. And then over here, that gives me 5x equals +2. And that leaves me with x equals 2/5. So those are my roots. It says, okay, now go ahead and put those on your number line. Put them in order. So I have -3/5 here, and I have a +2/5 here. And again, I'm going to go ahead and box those so that they stand out. Those are the values I'm concerned with. All right. Now it says select convenient test points. So we have 3 sections. So a number less than -3/5, I'm going to go ahead and just pick -1, pretty easy. Between a negative and a positive is always 0. And then greater than 2/5, I'm going to pick 1. Okay, so I'm going to just kind of show you down here again. You're putting your test points into the function, okay? And remember, what we have is 5x plus 3 times 5x minus 2. We're interested in knowing if it's positive or negative when you put the test point in. So let's put -1 in. When you put -1 in here, you get -5 plus 3, which is a negative value. When you put negative 1 in the second part, you get negative 5 minus 2, which is another negative value. A negative times a negative is a positive. So this section is positive. Let's put 0 in. When you put 0 into 5x plus 3, you get positive 3. When you put 0 into 5x minus 2, you get negative 2. A positive times a negative is a negative. The last part, we're going to take 1 and plug it in. When you plug 1 into 5x plus 3, you get a positive. And when you plug 1 into 5x minus 2, you also get a positive. A positive times a positive is a positive. Okay, so now we look back at what was our original question asking. Well, it was asking for values greater than or equal to 0. So that's positive values, the positive sections. And since it's equal to, that's referring to values that are on or above the x-axis. Okay, so the positive section. So I want this section over here and this section over here. I need to write those two sections in interval notation. So the first section is negative infinity. So I'm going to go scroll down. The first section is negative infinity to negative 3/2. And since it's greater than or equal to, I'm actually going to use brackets. Okay, because I want to be on the x-axis as well. Union, and the other section is 2/5 to infinity. Those are the sections where the graph is on or above the x-axis. 3. Solve the inequality x cubed minus 2x squared minus 35x is less than or equal to 0. As you can see, we already have 0 on the right-hand side. So my next step is to go ahead and factor the left-hand side. Now notice that all three of these terms have an x. So the first thing I'm going to do is factor out a GCF, which happens to be x. When I factor that out, that leaves me with x squared minus 2x minus 35. And again, it's less than or equal to 0. Now I need to factor this polynomial, this quadratic that's in here. So I have x, and then I know I'm going to factor into two pieces. So for x squared minus 2x minus 35, I need factors of negative 35 that add up to negative 2. Those factors are going to be negative 7 and positive 5. Okay, now that I have it factored, I want to set each of these factors equal to 0. So I have x equals 0, x minus 7 equals 0, and x plus 5 equals 0. That leaves me with x is equal to 0, 7, and negative 5. Now I'm going to place those on my number line. Okay, put them in order, negative 5, 0, and 7. Now notice this time it breaks the number line into 4 parts. Okay, so again I'm going to box these so that they stand out. Those are the zeros or the roots that I'm interested in. And now I need to pick test points in each section. So I'm going to pick negative 6 over here. I'm going to pick negative 1. I'm going to pick 1. And I'm going to pick 8. Okay, I would pause at this point and plug them in, do your test, and then play the video and see if you come out with the same thing as me. So in this section right here, I got negatives. In this section, I got positives. Here I got negatives. And here I got positives. Now I go back up here and I say, okay, what was I really looking for? I was looking for values less than or equal to 0, so the negative sections. But since it says less than or equal to, I really want values that are on or below the x-axis. On or below the x-axis. So that's talking about these negative sections. Okay, so how do I write that in interval notation? Well, this first section is negative infinity to negative 5, and we want negative 5 included. Union, the next section is from 0 to 7, and 0 and 7 are both included. So those are the two areas where this graph is on or below the x-axis. Example 4. Solve the inequality x cubed minus x squared is greater than or equal to 0. So again, we have 0 on the right-hand side, so we're going to go straight to factoring the left-hand side. Notice we have a GCF again. The greatest common factor is x squared. That leaves me with x minus 6 is greater than or equal to 0. I can't factor any further, so I take each factor and set it equal to 0. So x squared equals 0, and x minus 6 equals 0. To solve for x, I take the square root of both sides. Okay, remember plus or minus, but positive and negative 0 are the same thing. So that's going to give me x equals 0 and x equals 6. I'm going to take those values and put them on my number line and pick test points. So I'm going to pick, actually let me box these first. I'm going to pick -1, I'm going to pick +1, and I'm going to pick 7. Now, what I want to do is I want to test those, okay? So when I test them, when I put -1 into here, -1 squared is a positive, and -1 minus 6 is a negative. A positive times a negative is a negative. When I put 1 in, 1 squared is positive, 1 minus 6 is negative, so a positive times a negative is negative again. And then this last section, 7, when I put 7 into x squared, 7 squared is a positive, 7 minus 6 is a positive times a positive is a positive. Okay, so notice that this time it didn't alternate, and that's okay. It's not always going to alternate signs. So now let's figure out what the question wants. We want values that are greater than or equal to 0. Okay, those are positive sections. All right, since it's greater than or equal to, I want on or above the x-axis. On or above the x-axis. Now, that means I just want this section right here. Okay, but this one is a little tricky. Do you agree that 0 is also on the x-axis? This little spot right here? Okay, so that value actually needs to be included as well. So let's first write this section right here. This value is greater than 6. That's written 6 to infinity. Now, I don't want a whole nother section. I just want to incorporate this one extra value. So the way I write that is union just that one value. Okay, so that is my answer. Now, if the problem were simply greater than, if it just said greater than, then my answer would be 6 to infinity only. Okay, so make sure you notice the difference between what this problem is asking and what it would have been if it were just simply greater than. Solve the inequality x minus 5 squared times x plus 3 is greater than or equal to 0. Again, we already have 0 on the right-hand side. And in this case, the left-hand side is already factored for us. So what I'm going to do is I'm going to take each factor and set it equal to 0. So x minus 5 equals 0, and x plus 3 equals 0. So that's going to give me x is equal to 5, and x equals -3. I'm going to go ahead and put those on my number line. -3 and +5. Okay, and then I'm going to pick test points in each section. So a number less than -3 would be -4. Between -3 and 5, I'm going to pick 0, and greater than 5, I'm going to pick 6. Okay, and then I'm going to test values. So let's put -4 in. When you put -4 minus 5, you get -9, but a negative squared is positive. Then -4 plus 3 is a negative. So a positive times a negative is negative. So that section is negative. When I put 0 in, 0 minus 5 is -5. -5 squared is a positive. And then 0 plus 3 is positive, so a positive times a positive is positive. Now, 6. 6 minus 5 is 1. 1 squared is positive. 6 plus 3 is positive. A positive times a positive is a positive. So notice we have another one that didn't alternate, okay? We have positive and then positive again. So now going back up here, let's look at, they were asking for positive values greater than or equal to 0. So they want the positive sections. All right. So they want the values that are on or above the x-axis. On or above the x-axis. So that's going to be this section and this section. Okay, so let's write those two sections out. This first section is from -3 to 5, and since it's on or above the x-axis, we're going to include those values. So that would be -3 to 5. Union, the next section is 5 to infinity, and again, we're going to include 5. But you should notice something here. What have we done to the 5? The 5 is included. So instead of writing it as two separate pieces, the more accurate way to write this is from -3 to infinity. Because we're including 5, we don't have to stop and pick back up there. So my answer would simply be -3 to infinity. Now, I want to point out something. Let's say this problem were just simply greater than. Okay, if it were just greater than, then what I would do is I'd have to just write those two sections separately. If it were just greater than, my answer would be -3 to 5 with parentheses, union 5 to infinity. Okay, so the fact that it's greater than or equal to makes a big difference in your solution. I also want to show you what's happening with this graph. Okay, I know that my zeros are -3 and 5. I also know, if I go back up here, what is the multiplicity of 5? Well, the multiplicity is 2. Remember, if the multiplicity is even, it's just going to touch the x-axis and bounce off. The multiplicity of the -3 is 1, so it's actually going to cross the x-axis. So when I look at that, here's kind of an idea of what this graph kind of looks like. Whoop. Okay, so it crosses through -3, but then it just touches and bounces off at 5 because the multiplicity is even. So that's why we have negative and then two positive sections in a row. So again, the answer to this is -3 to infinity. But I just wanted to kind of show the relationship between if it were just simply greater than, and then why we have positive and positive next to each other based on the graph.